Alright, adjust the index error adjustment screw until you bring it together. Seems it was a long walk from the car park. Okay, so those three errors are your three adjustable errors. Alright. You filming this?
Yeah. Because you'll forget it after some time. You need to revise it.
I'll find it on YouTube. I'm seeing you. Three adjustable errors. Alright. There are four more. We'll recap those in a minute. If you can't get down to zero error, we might find we end up with a small index error. We just tweak the micrometer drum to measure the residual index error. Bring the horizons down together again and measure it. A few people were asking me about reading sextants, alright? So let's just be clear. This is the number of degrees. This is the number of minutes. Now any scale, whenever you read it, you've got to get context, you've got to get focus. So if you've just got a mark, which mark is it? Well, look at the last one that's marked, that's got a number with it. You know, if we were up here somewhere, up on, I don't know, that one. All right. So just look for context. It's clearly between 40 and 50. It's halfway between 40 and 50 is 45. We're at 46. We're nearly at 47, aren't we? So we're 46 point something. All right. And then when you come down here and you look at the micrometer drum, the same again. Just look at which mark we're between. All right. So we can get a feel for where we're at. Now, in this particular case, this is representative of an index error, and we are off the arc. I don't know if you can see it from back there, but it's just below zero. All right. So we've got an index error that's off the arc. This sextant will always underread. We need to know how much it's going to underread by, because then we can just add that back onto our reading. So it's just below zero. It's not anywhere near -1 or 1 degree off the arc. It's just below zero. So let's have a little look. How many minutes? Well, normally on this drum you'd read that as 50, 55, 56, 57 minutes, wouldn't you? But it can't be 0 degrees 57, because that would be really close to 1 degree off the arc, and we've just said we're not there. And of course the thing is, when we're below zero, we count backwards, don't we? Yeah? So you know, from 0 it goes 1, 2, 3, 4, 5, but we count backwards going the other way, minus and so forth. So actually, below 0 we need to count this backwards. So from 0, 1, 2, 3 minutes off the arc, below 0, off the arc. Alright? So here's another example now. Unfortunately the picture's not so clear. We're on the arc, right? I'm just above 0 now. You might not be able to see that because it's not such a clear picture, sorry about that. So it's just above 0. How much above 0? Between 0 and 5, so we're going 0, 1, 2. We're not quite at 3 though, are we? Alright? Now you could just eyeball that. I'm going to read it next to this blob, by the way, alright? We could just eyeball it and say, I don't know, that's about 2.9. And with the German ones, that some of us have been using, that's all you can do, alright? But they've got quite a large scale with quite big gaps in between. So you can just eyeball it and get a reading down to 1 decimal place. With these Chinese ones, you've got this vernier scale down here. So the way you're going to read that, each one is worth 0.2. So it's 0.2, 0.4, 0.6, 0.8, and then a whole 1 at the bottom. So all you do is you look and see which one corresponds with a mark on the main scale. It doesn't matter what it corresponds with, it's just got to line up. It's 0.2, does that line up with anything? Nah. 0.4?
Yeah.
0.6?
0.8.
0.8, by the time we get down to 0.8, we've got, let's see if I draw it place. Oh, there you go. Quite a close alignment there. So you're going to read that as 1, 2, but not quite 3 minutes. So 2 point something, 2.246, no, 2.8. It's 2.8 minutes on the arc. It's above 0. This sextant will always overread. So we need to take 2.8 minutes off of any reading that we take with the sextant. Alright? Happy?
Yes.
And just to wrap up, the other errors, if you get presented with a sextant in the orals room, being able to quote these errors is probably useful to you. The other ones are not adjustable, nothing you can do about it, just know they're there. Prismatic error is errors associated with the filters and shades. The fact that the light bends as it goes through the glass that makes up those filters and shades. Collimation error is similar, but it's light bending as it goes through the telescope. Graduation error is any errors associated with the scale, the mechanism, this whole part of the sextant down here. We've got the etching here, we've got the etching on there, we've got how well those two correlate with each other. There's a worm drive mechanism inside there, and the whole lot, again, we're striving for perfection. If it's anything less than perfection, which is it's never going to be perfect down to atomic level, so there will be a graduation error. And the last one is centering error. That's the fact that the index bar, with the index mirror attached to it, should be centered smack bang in the middle of that circle. Alright? So if we extended the arc all the way out into a full circle, this should be smack in the center of it, and again it won't necessarily be exactly in the right place. So those 4 non-correctable errors, we just live with them, but they should have been measured. So we've got some sort of values that